rocket science or a change of momentum. We'll look at that in a minute. Did you write the title? Good. Okay.
Will this be in the essay?
What does your heart tell you? Maybe? Which exam?
The final exam.
Final exam, I haven't a clue. Could be in the final exam. I have seen it in the exam before, yes. Okay. Right, another way to state Newton's second law is F equals delta P over delta T. And let's explain what they are. Delta P is the change in momentum per time. And momentum, so what the heck is momentum? Momentum is just mass multiplied velocity. Momentum is mass multiplied velocity. That is P equals mv. This is something maybe you remember from school even. So another way to state Newton's second law is force is the change in momentum over the time taken. We will show that this formula actually makes the same formula as the previous one we've seen, F equals ma. But for now I just need you to write this down. And what's the units for momentum? No.
Kilograms per...
No.
Grams.
No.
Not per.
Huh?
Not per.
Not what?
Not per kg meter square. Yeah.
No.
Yeah, it's not it, but cube.
Cubed? No. Dudes, wake up. What unit is mass?
kg.
And V?
Meters per second.
Yeah, so it's kilogram meters per second. That's not what you said. You were going to say kilograms per... No, you weren't. You said kilograms per, and then I stopped you. It's kilogram meters per second. Just keeping you on your toes.
What's above the T? Delta T?
Change in time.
Delta P.
Delta T. Is that like a 1?
1? What? Where are you seeing this one? This mysterious one?
No, he's
Right above
saying
it.
the one.
To the right. To the right?
This?
Oh, yeah.
Oh, that's a comma.
Oh.
We have maths at 4 o'clock as well. It gets in CAD. CAD is a more comfortable room.
Is it just us or is it
No, I think it's with the other students too. Don't worry. They feel the same way about you as you feel about them.
No, it's about moving fast, it's not about...
I know. Okay, do you have this written down? So you definitely need the definition for the exam. Momentum is the product. Oh my goodness! nobody noticed my spelling mistake.
I've noticed it, but I was like, what?
But I kept saying product, and you're like, but it's
Oh,
produce.
no,
The product of mass and velocity, not the produce. Produce is food. You can't eat momentum. Produce. Balls. Alright. Do you have this? So now, I'm going to prove that this formula is the same as F equals ma. Okay. So what happens here is, we have a mass, and its speed, its velocity is u, and then its velocity increases to v, and here the time is 0, and here the time is t. So, Newton said F equals change in momentum over change in time. That would be the momentum at the end minus the momentum at the start, the time at the end minus the time at the start. In other words, that's mv minus mu over t minus 0. That's mv minus u over t. But you might say, well, v equals u plus at, so a equals v minus u over t. So you can put that in there and you get ma. So you can say F equals ma, or you can say F equals the change in momentum over the time taken to change the momentum. This proof is...
Have opened the exam.
I'm trying to think. I think it's not really an exam question, but I saw one question in the exam once where you had to prove something very much like this. I think it's useful to know this proof. It's not really the proof itself, but the changing of the two formulas that's useful. You got this written down? You got this written down? Okay. Can I continue? Yeah? So why bother? Why bother with this new formula if F equals ma works just as well? Well, the reason is it's very convenient to use when the time is very small, or when we want to know something called the impulse. Impulse is the change in momentum. That is, impulse is the delta p. So if you need to know the impulse, then really you have to use that formula. Because you can kind of picture knowing the F, knowing the t, and wanting the delta p. Does anybody know why the delta p is important? It's called impulse. Does anyone know why delta p is important?
When the time is extremely small.
Yeah, but I suppose I should say, why do we care about the impulse? Like, of course we know why we care about the force and the acceleration, but why is impulse a thing we might want to know? Any ideas?
Same reason we want to know speed.
Something else. Impulse is important because impulse is what hurts. When a force is being applied, if you think about it like this, I can push with a force. Okay? So like if I push here with a force with a short time, that doesn't really do anything to him. But if I push with the same force for a longer time, more stuff happens. He moves a bit. So the force is important, of course, but it's more about how the momentum changes. If the momentum changes a lot, that kind of means something bigger happened. You know? again, like with the wall, I can apply a force, you know, for a long time or a short time. The time is also important. Yeah. The best example I can think of is when the car crashes. Okay. First, the car is going very fast, so its momentum is very big, right? And then the car stops. So what's its momentum? Zero. So would this be big or small or zero or what?
Big.
Be big, wouldn't it? Because it's MV, which is big, minus MU, which is zero. So in other words, this being big means something dramatic happened. Do you understand the importance of it? So when you're talking about collisions and safety and all this type of stuff, it's not the force that you care about, it's the impulse. Yeah? Okay. So can you write this definition down?
That is the L-I-L-I.
What does your heart tell you? Now go on, what do you think? I.
Can you go back to the second slide?
In a second, yeah. I know, Fuang, unfortunately when you type, it's the same, it looks the same as L. It's I. Why is it I? I for impulse. Okay, what slide? The previous one. Yeah?
We did not say that change in momentum is delta P over delta T.
We did not. Alright. You got this? You have this? Yeah? Okay. Here's a very simple one for you to do now. Tell me the impulse. Oh! And what's the units? Fuang's telling me kgm over seconds. Kilogram meters per second. Okay. Right, try this one for me. Should only take you 10 seconds. What did you get?
24,000.
Yep. Or if we use our prefixes,
No. 3 after kilo.
what is it? 24?
Kilo.
Nobody says kilo. Come on. What's kilo?
Kilo.
Come on, what's kilo?
Mega.
Thank you. It's 24 megagram meters per second. Or 24,000 kilogram meters per second.
Will they use prefixes in the exam?
You don't have to use prefixes.
No, like will they use them?
They could give you the information with a prefix and you'll have to convert it into 10 to the power. That is quite usual. You're not required to give the answer in this way. You can just use 10 to the power. But as the September students will tell you, I like using prefixes. I know some students don't like prefixes. Ron, how do you feel about prefixes? Yes. Okay, can you try this one? Now for this one, you may need to use the formula F equals delta P over delta T.
The nail?
Yes, you know nail? Not this nail. This one. In the wall. It'd be quite sore to hit this nail with a hammer. Yes. Quite sore. Okay, try this one. I'm looking for the force, and my hint is you'll need to use the new formula. Get the answer over there? And it is right or wrong? No, look deep inside you. Is it right or wrong?
Right.
It's good to believe in yourself.
Yeah.
Did you get an answer over there? No? Okay. Did you get an answer, Lee? You got an answer for this?
Yeah. Because that's just by looking at
I don't like that though. Alright, let's have a look. Any look over here?
I got
You got an answer, but you're not committing to it being right or wrong. No, okay. Good call. Right. What's the mass of the nail? 0.1 kilograms, yeah. And then the force, 50 newtons. And then it moves with a velocity of 4 meters per second. So, we have F equals ma. And we also have F equals delta P over delta T. Which formula should we use to start? The first one, which is, we have to use one of them first. Which one? 1 or 2? 2, yeah, 2. So F equals delta P, which is mv minus mu over t. And the t is what I want. So delta T equals mv minus mu over F. Right?
Yeah.
Okay, what's the m? 0.1. The v? 4. The u?
0.
And the f? 50.
Yeah.
Ah, so you were right, yeah? So what you get?
8 times 10 to the power minus 3. Yes.
8 milliseconds.
Yeah.
Or, if you prefer, 8 times 10 to the minus 3 seconds. Did you get this? Did you use milli? Did you use milli? No. Okay.
On you like it?
Yeah, I think so. Okay. Right, here's another one to try. Same idea. Except this time, I want the impulse. The delta P.
And the force.
Later I want the force, yeah. But I give you the time, 100 milliseconds. Milliseconds. Do you know? You know or don't know? You know.
Yeah.
For the first part? And the unit?
Yeah.
Now, if I didn't say this, I'm saying it now, and if I did say it, I'm saying it again. In the exam, forgetting the unit in the answer will cost you 1 mark each time you forget. I have seen students give me every answer without a unit, and that did cost them 1 grade. They went from a B to a C because none of their answers had units, even though the answers were the right numbers. Don't let this happen to you.
kg meter per second.
And don't use slash.
No slash.
The slash I take off and one thing.
It will just make me unhappy.
Like when you've been using a slash for about 11 years or so.
Actually, we didn't use that. For the last 2 years. But we used to.
He's just being difficult, don't listen to
I
him.
never used the -1 or -2.
That's why you're here. We'll get you up to standard, don't worry.
What is ms? 100 ms?
Milliseconds. Yes, that's right.
Sometimes 10 to the power minus 8.
Yes.
I was looking at the speed and
Yeah.
that's meter.
What's the difference between meters per second and milliseconds? No, seriously, like how can you tell the difference? How can you tell the difference? The space. I have it backwards, by the way. It's my typing. It's very bad. You can just note. I'm sorry. There should be a space here. There should always be a space between units, meters and seconds. There should be a space here. There shouldn't be a space here. I have it backwards. So this should be M, no space S. That's how you tell if it's a prefix or if it's a meter. Obviously, yeah. You can't kick with 10 milliseconds. Sorry, not even milliseconds, millis per second. Okay, does anyone have this finished? Will we have a look at it now?
Exponent -3.
For milli, yeah. Produce. Product.
So it's 25.
We'll have a look now. Okay. 250 grams, 10 meters per second. What's the impulse? So,
V minus U.
it's, yeah, we have delta P, the impulse, is mv minus mu. Is it 10 meters per second?
Yeah.
So that'd be 0.25 times 10 minus 0. That's 2.5 kilogram meters per second. Part B, what did I want? The force, was it?
Force, yeah. And the time is 0.1.
Ah, this is easy. I gave you too much time. 0.1. 25 newtons. Headache? Just sitting beside him? That would give me a headache.
Where'd you get the 0.1 from?
That's the 100 milliseconds in the question. 100 milliseconds is 0.1 of a second. Continue? Yep. Now, one of the biggest advantages of using this formula delta P over delta T is that you can use it to calculate the force provided by rockets and other propulsion systems. So if we think about the hot gas coming out of the rocket, it has a mass and a velocity. So the gas comes out, it has a mass when it comes out, and it has a velocity when it comes out. But the gas was at rest. So here, inside, the gas is not moving. Outside, the gas is moving. Therefore, its momentum changed. And we just learned from our Newton's formula, what's force equal to? Change in momentum over the time, the change in time. So if there's a change in momentum, it means there's a force. This, with Newton's third law and second law, will give us a nice formula to calculate the force. Let's see. So the proof is quite short, but just to be careful to understand it. So here's the rocket, and here's the gas coming out, and it produces a force upwards. Of course, it moves up. Now, let's say each delta t, and usually delta t is 1 second. So each second some gas comes out, and we'll say the mass is delta m for each delta t. So for example, it could be 100 kilograms per 1 second coming out. Yeah? Now, we want to calculate the force. Okay, so if you look here, we know that F equals delta P over delta T. The gas was at rest inside the rocket. So it's delta M, and let's say its speed is V. Delta M times V minus, if it was at rest in here.
Isn't it M times delta V? Because the mass won't change.
I'm using delta. Yeah, sorry. I should explain the symbol. Delta X has two meanings. I'm sorry to tell you. Delta X can mean the change in X, or it can also mean a small x. It has two meanings. So in this context here, I meant delta M as a small m. But if that's confusing, I'll just go to use m. Better? Okay. Minus what?
Yeah.
Minus 0 over t. So that's mv over t, or delta t if you want. Okay. Now, that's the force of the gas coming out. Will that be the same force as the force of the rocket going up, if you think about it? Yes. And the reason is, if we go back to Newton's third law, do you remember the picture I gave you for Newton's third law? What was it? The balloon. Balloon. So what happens here is the air comes out with a force. This force, it comes out here, will equal this force the balloon moves at. That is the reaction.
Considering there's no air resistance.
Consider no air resistance, yeah. In other words, you get this very simple formula that the force equals delta mv over t. And because we usually use 1 second, then it just becomes mv, where this is the mass of the gas per second, and then this is the speed of the gas. So just to summarize, I'll put in a box here for you. The force for the rocket is equal to mv. And it's very important that these are in units of per second, because there should be a t here, but it's usually 1. Because nobody says, 10 kilograms per 2 seconds. It's always per second. So this is a simple but very useful formula. If you know how much gas comes out per second and how fast the gas comes out per second, then you know the force that lifts the rocket. Okay, so I'd like you to write this down, please, and then we'll have a look at some examples. Do we have physics tomorrow, did we say?
Yeah, it's one lesson.
One lesson. Perfect. Okay. Continue?
Yes.
Go on? Continue, yes? Okay. Very simple one. I want you to give me the force of this rocket. So, what's happened here? The rocket, its mass is 4,570. At launch, the velocity of the gas is 4,462 meters per second.
20 minutes.
And then each second, 7,485 kilograms of gas is burnt and ejected. What is the upward force?
20 million Newton.
Look,
We have suffixes and prefixes.
give me the prefixes.
Yeah, 20 million.
Million is not a physics prefix.
Oh, fuck. 2 times 10 to the power of 7.
Give me a prefix.
20 mega.
That's better. Now, let's have a look at this one. You might realize that you actually don't need to know the mass of the rockets. I put that in to distract you. You only need to know the velocity of the gas and how much gas is used per second.
Wait, it's not something.
How much gas comes out per second? 7,485 kilograms per second. And how fast does it come out? 4,462 meters per second. So then the force of the rocket here...
33 mega.
Shh, please. Now we're talking. 33.4 mega newtons.
But can't you just ignore, like you can't ignore the weight of the rocket?
Of course not. You would need to know it to calculate the acceleration, because F equals ma, you know. But you don't need to know the mass of the rocket to work out the force from the engines. In this rocket, the engine force is 33.4 meganewtons. Okay. Okay. Try this one. I actually think it's maybe too hard for you to try, but what I would like you to do is to at least try to draw the problem, and then I'll do it now. So if you can just at least draw this one.
It's related to, do you need to find an area?
It's like the rocket question, believe it or not. So I'll just give you 1 minute to try and draw it, then I want to do this one. I think it's too hard for you to do.
Do you know the answer?
Give me your answer. 12 newtons?
Yeah.
Seems believable, but I would have thought, imagine you're walking into the wind. Does it feel like more or less than 12 newtons?
Because it's stationary.
It doesn't matter, you're still going to feel the wind pushing into your face.
12 is the speed of wind, isn't it?
The speed is 12.
So can the force be equal to the speed?
You're getting along the right idea. It's like the rocket one, where you need to know the speed and the mass of the wind.
Yeah, the mass
It's given to you cryptically.
I have an answer.
What you get?
7.68.
Now you see, this sounds too, it could be it, but it sounds too small, because if you think about standing in the wind, and the wind's blowing at you at 12 meters per second, which is a strong enough breeze, in total, is it going to be only 7 newtons? Because 7 newtons is, what mass gives 7 newtons? That's like it's like a bottle of water. So tell me, does having the wind blow on you feel like you lying on the bed with a bottle of water on your chest? I think the wind would feel like it's more than that. Huh? That's the type of number I'm thinking about. Let's see what we get. Right. Now here's the trick. First step is to picture the student not as a student, but as a rectangle. There's our student. How tall is the student? And how wide is the student? How fast is the student walking? 0. So he's at rest. And how fast is the wind blowing? 12 meters per second. So you only need to look at the wind that's 12 meters in front of the student, because anything that's here will not get to the student in 1 second. So you only need to look at the wind or the air that's right in front of the student, because this is what's going to hit him in 1 second. So in 1 second, think about this, in 1 second all the air here will hit him. That's what wind is, the air hitting you. So in 1 second all the air here will hit the student. So F equals mv, because it's like the rocket. The difference is instead of the gas coming out of the rocket, it's just the gas is just coming at you from nature. But it's the same principle. So we still can use the same formula mb. Do we know the m? No. But we do know the v. What's the v? 12.
We know the density.
Yeah, now we can know the mass because we have this formula. Density equals mass over volume. So what does what does mass equal? Density by volume. And I told you the density. What did I say the density was? 1. So this will be equal to 1v12, which will equal 12v. What's the volume of this shape? 12 by 0.4 by 1.6. Well, sorry, Fuang, you were close, but not quite there.
Why is that 0.5 and 1.6?
Because I need the volume, the V.
I use the area instead of the volume.
92.2 newtons. Okay, that's a hard one, but I have seen it on the exam once, long time ago, but I did see a question like this in the exam once. Quick question before we finish. What would happen if the student bends down so their height is now only 0.8? What happens to this? Half. So this is the reason people bend down when the wind is very strong, because you're reducing the force from the wind.
Or walk sideways.
No, well,
Sideways would be better.
Then bending and walking.
walking sideways? What do you mean?
Don't walk like this, walk sideways. So
Oh, even less area. Yeah, so not, well, why not walk? Okay, yeah, okay. So, yeah, walk, so you're reducing it this way.
Yeah.
Yeah, okay.
There's bits where it would be smaller than half.
Yes. It depends on the person. Some people might still have a significant sideways length. Yes. It could even be more. Yes. Yes. Whereas if you duck down, it's going to be half for everybody. Yeah. Okay. So let's see here. Right.
Enough, please.
What?
This will be homework.
Yeah. Just relax. Relax. So the questions are a bit tricky, but question 1, 2, 3, these are all exam questions. Now number 4 could be on the exam, but not as difficult as this number 4.
Are these on Moodle?
These are on Moodle, yeah, but this video will be uploaded after class probably. Depends how busy I am. I'm quite busy, as you can see. Right, we will do maths in a few minutes.
All of them?
What does your heart tell you? All of them.
Okay.
But deep down you knew the answer already.
Yeah.
Yes.
For tomorrow?
For tomorrow. Yes. But I don't think we'll get a lecture fully covered tomorrow, so there shouldn't be any physics homework for the weekend. So there's pluses and minuses.
Yeah, but